All right, guys, I have good news and I have bad news. Good news is that today, this is the only video you actually have to watch this week. I will be posting a video like reviewing for the quiz if I think that you need it, but I will warn you this video may get a little lengthy. So please just be aware that this is the only video I'm hoping that you have to watch this week. So today we're going to be talking about similar polygons, and everything that we've been doing up till now has led us to today. And we've talked about congruent polygons, but we're going to chat about similar polygons now. A lot of people have reached out asking for copies of these notes. If you want a copy of them, stop by my room. If you have a printer at home, let me know. I can email them to you, but definitely it helps, I think, to fill these out along with me. So what similar polygons are, they are polygons with the same shape. So they're going to look the same, but they're going to have different sizes. So one's going to be big, one's going to be small. You know polygons are similar if, and these two things are going to be the big things that we are going to use today. So polygons are similar if the corresponding angles are equal. So angles will be exactly the same degree measure. So if one has a 50-degree angle, the other one will have a 50-degree angle. The difference is this right here, is that the corresponding sides are proportional. And that is why on Friday we spent that time solving proportions, because the sides, then you're going to set up the proportions of the sides and it'll help you to solve. So the ratio of the sides, or how you can figure out how they're similar, the ratio of the sides is going to be called the scale factor. And the scale factor is kind of like the dilation factor or the dilation number. So let's take a look at a couple of examples of what you're going to be doing today. First thing we're going to do is look at our figures here. Order matters. So when we did congruent triangles and congruent figures, we really paid attention to how the letters were and matched them up based off the letters. You're going to do the same thing today with your figures. So it says, what is the scale factor of this triangle to this triangle? So I'm going to take these two sides, or this side AB, which has a length of 8, is going to correspond to this side DE, which has a length of 12. So you just set up a ratio, and then you're going to reduce it just like we did on Friday. 8 and 12 are both divisible by 4. So if I go from ABC to DEF, I put ABC on top, DEF on bottom. You have to pay attention to directions in that sense. But then reduce it down, and you have a scale factor of 2/3. Now let's say, like they want you here, it says, what is the scale factor of DEF to ABC? Now we're going to put, I'm going to use side DE, I'm going to put that on top, and then AB, put that on bottom. So it is different. You will get different answers depending on what the problem is asking. You need to pay attention again to directions. So then reduce it. 12 divided by 4 is 3. 8 divided by 4 is 2. So they're going to either be, they'll be reciprocals of each other. So first thing we're going to chat about today is something that we have already looked at, and they are dilations. So back in the reflections, rotations, translations group, we had these primes, and we actually did those when we did dilations. So the primes are what we ended with. So we started with this triangle. So this is what we started with. And then we did some type of a dilation or some type of a scale factor, and we ended up with this. So we started here, ended here. It says, is the dilation an enlargement or a reduction? Well, it got smaller, so this is going to be a reduction. And then they want to know, what is the scale factor then? What did I multiply these coordinates by to get these coordinates? So the easy way to find the scale factor with dilations, or really with anything, is that you take a side length of the new, or the end in this case, take a side length and divide it or write a fraction over the old side length, or where you started. So you put the new side length over the old side length. So to find our scale factor, a new side length would be like this length right here, which is just 1 over an old side length, though A prime, B prime matches up here, we go 1, 2. So we have a scale factor of 1/2, which makes sense because if it's a reduction, your scale factor has to be less than 1. So let's take a look at another one like that. I know I may be going a little bit quicker than I would like, but you guys can pause this and rewind and all that fun stuff. So if we take a look here, we start with the non-primes and we end here. This is going to be an enlargement. And then they want to know the scale factor. So scale factor, you do new over old. New side length, 18 over old side length, 12. 18 and 12 are both divisible by 6. So we get 3 over 2, which would be 1.5. It's greater than 1. That's how we know it's an enlargement. So that is one thing that you could possibly have to do today. Another thing is you are going to start having to write these similarity statements. So we did congruence statements, and it's where you match up we matched up the congruent sides and the congruent angles. For similarity, you are going to match up the congruent angles, but then the proportional sides. So the symbol that we use for similar is this little tilde here. And how you would write a similarity statement would be like triangle ABC is similar to triangle DEF. So instead of putting congruent in between, you put the little similar symbol. So what we're going to do for this example right here, and this is the only one I'm going to really walk you through, is we're going to list out the angles that correspond and then the sides that are proportional. And honestly, not having the picture is a little bit better because you can use the letters to help you and guide you. So we're going to list out our congruent angles first. So angle J is going to be congruent. J is the first letter, corresponds to angle P. Then we go to angle K. That corresponds to angle M. And then angle L corresponds to angle N. Now, sides, sadly, it's not as easy as just saying this equals this, this equals this. You've got to set up your ratios. They're proportional. So you're going to need 2 letters. So JK, first 2, is going to be proportional, or it's going to match up with PM. Those sides match up. Then I'm going to do last 2 letters, KL, correspond to last 2 letters, MN. And then the last pair are the first and the last, JL, matches up with PN. And knowing which sides and angles and stuff like correspond with each other is going to help you to solve for unknowns, which is where we're going right now. So when we are finding side lengths, and like I already warned you, I'm actually going pretty good right now. We might actually end this before 15. I'm feeling pretty good. When we are finding side lengths, you are going to use proportions. So you're going to have this over this equals this over this. And you're going to be doing a lot of cross multiplying. I'm probably not going to do all of these examples because, like I said, you can pause, rewind, and it's going to save you some time to have to listen to me. For number 4, it says, if the figures below are similar with a scale factor of 2 to 3, so 2 over 3, find the value of x. So when they write your scale factors, they always go left to right. Or here we go small then big. Well, this is clearly the smaller parallelogram, small, big. So the smaller number is going to match up with the smaller figure. So 2 over 3 equals 42 over x. That's how you set up your proportion. So then, like Friday, do your little butterfly method or cross multiply, and you get 2x equals 126. Divide by 2, x equals 63. So you would do the same thing here. It says the figures are similar by 6 to 5. So 6 over 5 equals big over small, so big over small, x over 28. And you would go through, do your awesome algebra skills, and you will get decimals. For this one, you would get 33.6. So if you want to practice this one, make sure that's what you get. That's how you're good to go. For number 6, now they don't give us a scale factor. We need to use our directions to match up the sides that correspond. So AB has the X. So I always use that as my like starting point. So X, which is on AB, AB corresponds to DE. So X over 25 equals, and then you take the other two sides. So I did X over 25, and then I have to go back over here, 28 over 20. 28 over 20. So you're matching up or writing fractions of the sides that correspond with each other, and then you're going to cross multiply. 20x equals 700, divide by 20, x equals 35. Same idea for this one. X is on this side RS. RS are the last two letters. YZ are the last two letters. So X corresponds to 32. I went this over this, so I have to go back to here, 75 over 40. Go through, do your algebra, and you should get X to equal 60. And again, use that to kind of help yourself out there. Practice that one. Let's see. This is kind of doing the same thing except for you're solving for X and Y. I think I'm just going to give you the answers to this one, and if you want to practice, you're going to have to set up, X is going to have to correspond to, well, maybe I will do this one. Let's see, X is on GH, GH last first, FD is 12. So X corresponds to 12. Now, the hard part is that obviously when you come back to this triangle, you don't want to use this side. You're going to want to use this one because it has a number on it. So we're going to do 15 over HJ. HJ, first and middle, is going to correspond to first and middle 9 there. So then you cross multiply, do your awesome algebra. You should get X to equal 20. And then same idea with Y. And I want you to try that one on your own. I'm going to tell you the answer is 23.3 repeating, but I want you to see if you can actually figure out how to set that up. Any issues with that one, please reach out and ask, and I am available for questions. All right, last two. I know it's a lot, I'm sorry. But like I said, last video of the week. So here again, they want us to, we're going to solve for X, and then we're going to plug it back in and find the length of LY. So LY is this right here, which is 4X minus 1. LY, last two letters, corresponds to X plus 5 equals, so I went this over this, so I have to go back over here, 25 over 10. And then you're going to cross multiply. Now remember, if you're taking 10 times 4x minus 1, that means you take the 10 times the 4x and 10 times the negative 1. So you get 40x minus 10 equals, same thing here, take 25 times x and 25 times 5. And then you have your algebra to do. Subtract 25 and you get 15x equals, add 10, you get 135. Divide by 15 and you get x to equal 9, which is great, but the problem wants you to find Ly. So Ly is 4x minus 1. So you do 4 times x, which is 36, minus 1, which is 35. All right, last one. This one looks a little funky because you have a triangle within a triangle, but we are just going to read the directions here. It says BR is 4x plus 7, so we have 4x plus 7 over, so BR matches up with BN, which is just 12, equals, and then BG is on that triangle where that BR was on, so 18 over, BG are first and last, so first and last is BV, so 8. So that 10 is there to confuse you, so hopefully you didn't fall victim. And then you're going to cross multiply, and again you have to take the 8 times the 4x and 8 times the 7, 18 times 12, subtract the 56, divide by 32, and this one you just need to get x to equal 5. I barely made that under 15 minutes. So today you are going to be working on these types of problems, and again tomorrow you're going to be working on these types of problems. Tomorrow there is no video, just an assignment. And then for the next day or so after that, actually for one day you're going to review. Thursday is your quiz. You must show all of your work on your quiz. Any questions, comments, concerns, don't hesitate to reach out, guys.